Hey, welcome back to Math with Patrick. Today's October 2nd, and we're solving problem 275 from the Daily Epsilon calendar. And the answer today should be 2 because it matches today's date. So we have some kind of trig problem here where we have some fraction, some ratio of trig functions, and once we square it, we get the number 2. So that at least shows me that this number right here is root 2, or maybe negative root 2, because once we do a negative times a negative, we would still get a positive. So one of those values. Um, and solving these kind of like trig or evaluating these trig expressions here, usually I like to have the same angle here, here, and here. There are some identities we could use as long as the angle is all the same. And so the fact that they're all different makes this problem pretty hard. So kind of operating under that assumption that I do want to have all the angles the same, let's maybe rename the numerator. I know that I could change this sine of 50 into a cosine of 40. And let me just kind of quickly prove it to you. Let's just say we have a right triangle here. This is 40 degrees. This is 50 degrees. If I do cosine of 40 degrees, cosine is defined as the adjacent side over the hypotenuse. So I'll do like a over h. So this cosine of 40 is just a over h. And then sine of 50, sine is defined as the ratio of the opposite leg divided by the hypotenuse. So opposite of the 50-degree angle is a again. So opposite over hypotenuse is going to give us that same ratio, a over h. So for starters, I have at least matched the 40 degrees with each other. And I do know that there's another trig identity where if we have like a sine squared of some angle plus cosine squared of the same angle, we get always 1. This kind of follows from if you study like the unit circle. Essentially, we would have like a circle whose radius is 1. Sine is always going to be this vertical distance, and cosine is always going to be this horizontal distance. And it's essentially just the Pythagorean theorem, but written with trig functions. And expanding this numerator with this square is going to get me something kind of like that identity. And so I figure, why not? Let's expand that square. So we are going to get sine squared of 40. I'm doing this times itself. Then I do need twice this product right here. So 2 times sine of 40 times cosine of 40. And then finally, we get the last times itself. So plus cosine squared of 40. And the denominator, let's just call that cosine squared of 5, because the square can apply to the numerator and the denominator separately. So going off of that kind of Pythagorean identity there, I know that sine squared of 40 plus cosine squared of 40 is just going to be 1. So, let's do 2 sine 40 first, just to match what's already going on in that numerator. And I only want to change one thing at a time. Okay. And it kind of simplified a little bit because like now I have 2 angles that match. I only have one thing being squared, not many. And this right here is actually another trig identity. 2 sine x times cosine of x is equal to sine of 2x. And so essentially this format lines up right here perfectly. And I can kind of reduce it down to just one sine function as long as I take the angle here and double it. So I will do 1 plus sine of, and then double 40 is 80. And I still do have cosine squared of 5 in the denominator. And this isn't really fun. I don't like having that squared, really. Although, fortunately, there are these kind of other squared identities, ones that are different from this Pythagorean identity that I just did. This one reminds me of kind of like the double angle identity for cosine. I also know that cosine squared of x is equal to 1 plus cosine 2x all over 2. And all I need to do to go from this to that is double the angle, right? Because it goes from x to 2x. And then I also need to include that like plus 1 and divide by 2. So we do get 1 plus sine of 80 all over 1 plus cosine of 10 divided by 2. And let's rewrite this. I don't like doing fractions within fractions, but I do know, just kind of like using like fraction arithmetic strategies, I could rewrite the numerator with like a divided by 1 here. And I can rewrite division as multiplication as long as I flip the bottom fraction. And we're kind of getting closer. And let's actually use one more of the same identities that we used earlier, essentially proving that sine of 50 and cosine of 40 are the same. We can do the same trick with cosine of 10 and sine of 80. These two numbers are going to be equal to each other. One quick way to check is that the 80 plus the 10 makes a 90, just as this 50 plus the 40 makes another 90. So I can rewrite the denominator on the right side as 1 plus sine of 80. I'll keep the 2 where it is. And then 1 plus sine of 80, whatever that value is, I do have it on the top and the bottom of my fraction, and those two factors are going to cancel. So we're just left with 2 divided by 1, which is 2. Great. That's what we wanted to find today. So I don't even know if this value is supposed to be root 2 or negative root 2. But I do know that just like based on all these identities, we do get the value 2 out of this number. So there is my solution. Hope you enjoyed. And I just realized that this is the number positive root 2 because sine, and cosine, all of these are going to be positive values because they all kind of live within the first quadrant of kind of our unit circle. So we do get a positive root 2 out of all this mess, but we didn't really need to know that squaring this value does give us the 2 for today. So I'm all done. Thank you for watching, and I will see you tomorrow.